Okay, what we're going to talk about today is water. And specifically, when we're talking about water, we're talking about why it is such a vital component to life on Earth. And so, as your topic, please indicate that it is water. For your essential question, why is water vital to life on Earth? So, when we're talking about water, it's important to realize that we're actually going to be talking about 7 particular properties of water that make it so important. And again, we're looking at why water is important to life on Earth, not all of the properties of water, but ones that are specific to biology. So, just a brief overview of the 7 that you need to know in regards to water. Water is a polar molecule, so you need to know how polarity affects it and makes it effective at what it does. You need to understand cohesion, adhesion, and capillary action. How are they similar? How are they different? How do they help life to exist? 5 is a big one because we're going to look at the importance of water in regards to temperature control. And this temperature control is going to be based both on the Earth as a whole, the ecosystems, the biomes, the biosphere, but also for the organism itself. Then we're going to look at why the fact that water's solid form, or ice, being less dense than its liquid form is important, and so why ice floats. And then number 7, we're going to look at water in regards to it being the universal solvent. So first of all, we need to talk about the fact that water is polar. So remember that polarity is the uneven distribution of electrons between atoms in a molecule. And so if it was truly covalently bonded, the electrons spend an equal amount of time around all the atoms in that molecule. However, sometimes that sharing is not equal due to the fact that one of the atoms or elements is far more electronegative than the other. So in water's case, oxygen is the more electronegative one, and that means that oxygen is greedy to a much higher degree than hydrogen for those electrons, and so the electrons end up spending much more time around the oxygen, which, as we know, if we add electrons to an element, it becomes more negative. And then since those electrons are around oxygen more, they're actually spending less time around hydrogen. And if you lose electrons, then it becomes positive. So in this case, water ends up having slightly positive side, which would be where the hydrogens are, and a slightly negative side where the oxygen is. The next property that we're going to talk about in regards to water is the property of cohesion. And cohesion is the attraction of molecules for other molecules of the same kind. So in this case, hydrogen bonds between water molecules hold them together and increase cohesion. And so when we're talking about this, what it really means is the fact that water molecules are attracted to other water molecules. And this attraction occurs because of hydrogen bonds. So the hydrogens on one water molecule bond through a hydrogen bond to the oxygens of 2 other molecules. And so by doing this hydrogen bonding, we end up with a lattice work of bonds that is going to allow water to move against gravity. It is responsible for surface tension, so the fact that like water striders can actually walk across the top of water, that's due to its surface tension. This is the property that allows water to resist external force. So you have to actually push fairly hard on water to get yourself to go through it. Why boats float. And then, of course, remember that the definition is water molecules sticking to other water molecules, because in cohesion, there is an attraction to molecules of the same kind. That's different than adhesion. Adhesion is where water molecules, or molecules in general, are attracted to molecules of a different type than them. So in the case of water, if we look at our picture here, you can see that we're in the xylem of a leaf, or the tubes, the veins of a leaf, and you can see that the polarity again comes into effect, because here we're looking at the fact that there's a bond between this negative oxygen in that xylem of the leaf. And so again, polarity is giving it this ability. So what makes the adhesion so important? Well, in plants, it allows water to cling to the cell walls or to those veins, if you will, in the plant. And that allows water to not go back down. So it basically acts against gravity. And so remember that adhesion is water's attraction to substances or to its container, so other things besides water molecules. If we take and we put capillary action, or if we put adhesion and cohesion together, we get capillary action. And capillary action is going to be the upward movement of water due to the forces of cohesion, adhesion, and surface tension. And so this is extremely important for plants because this is how water that's clear at the bottom of a tree gets all the way to the top where all the leaves are. Capillary action can only occur when adhesion is greater than cohesion, and it is how water moves upward. And you can see capillary action occur. If you've ever stuck a straw in water, it actually moves up higher than the level of water, and that's that capillary action. So now let's move on to our next property of water that makes it so important for life here on Earth, and that's temperature control. So water is very special because it has a really high heat of vaporization or a high specific heat. So what does that mean? Well, that means that water resists changes in temperature. It takes a lot of energy to change the temperature of water even 1 single degree. And so how is water so able to resist that change in temperature? Well, it's hydrogen bonds once again. So heat has to be absorbed, and heat in this case is our form of energy, and it's what we're measuring with temperature, but it has to be absorbed in order to break those hydrogen bonds. But then every time those hydrogen bonds reform, more heat is released. And so it takes a lot to overcome that process. And so what actually happens then is we end up with this ability of water to moderate air temperature. And so in order to do this, large bodies of water absorb heat all day long, and then they release heat at night. And so this stabilizes the ocean temperature, which benefits marine life, but important for us as humans because we're water-based. We, amongst other organisms, are water-based, and so it actually allows us to maintain that homeostasis as far as temperature goes because it helps us to control our internal temperature. The other side to temperature control as far as the properties of water go is something called evaporative cooling. And so this is that high heat of vaporization. So molecules with the highest kinetic energy are going to leave as a gas. Okay, and so you're literally vaporizing or going from a liquid to a gas with evaporative cooling. And so why is this important? So this is how the Earth moderates its entire climate. It stabilizes the temperatures in lakes and ponds. It prevents terrestrial organisms such as ourselves from overheating through the process of sweating. And it prevents leaves and plants from becoming too warm in the sun. And so really, evaporative cooling and high specific heat come into play to regulate temperature both in the entire biosphere as a system, but also within, at a smaller scale, within organisms themselves. The next property that we need to talk about is the fact that ice floats. And so again, it's very unique that water's liquid form is actually more dense than its solid form. So normally it should go the other way. So as water solidifies, it expands and becomes less dense. And again, this is going to be due to hydrogen bonding. So when cooled, water molecules move too slowly to break those hydrogen bonds, and so they break out into that lattice shape like you see in the picture. And so this allows marine life to survive under floating sheets of ice, which would be important since we wouldn't want to kill off all of an ecosystem every winter. The final property that we need to talk about in regards to water is the fact that it is our universal solvent. So let's do some definitions real fast to make sure we understand what we are referring to. Solvent is going to be the dissolving agent in a solution. Water is a versatile solvent because it's polar, and so other polar molecules or ions as well are attracted to water, and we form those hydrogen bonds with those particular substances. So when we're looking at solution, our definition is a homogeneous mix of two or more substances. Remember, homogeneous means it looks the same, it acts the same, even though it's two different substances. Solvent, again, is the dissolving agent, and solute is the substance that's being dissolved. So if we look at this, like dissolves like, so that's why there has to be a charge. So it's either ions or polar molecules. So water can interact with sugars and proteins that have lots of oxygen and hydrogen. Water forms hydrogen bonds with the sugar or the protein, and that dissolves it. And so with ionic compounds, it's a similar process, but the partially negative oxygen in water interacts with the positive side of the ion's atom. The partially positive hydrogen interacts with the negative. And so that's how ions are dissolved. And so if we look at our example here, we've got table salt, sodium chloride. We add it to water, and you can see how the sodium and the chlorine interact with those water molecules. So that is everything we're going to discuss in terms of the properties of water. Take a minute now and answer your essential question at the end of your notes in regards to summarizing what you have learned today. Be sure that you took time and added diagrams to your notes as well.